Okay, this set of notes is on operations with complex numbers. On the board for bell work, you'll see things that we have done before. We are going to add to binomials or adding polynomials. Number two, we're going to subtract polynomials. Number three, we're going to multiply polynomials. Okay, this again applies to things that we will do in this section. All right, so number one, my suggestion with addition was to just remove the parentheses. So I have 7 minus 5x minus 3 plus 8x. And then I suggested underlining or highlighting like terms in a similar fashion so that you can see which ones go together and which ones don't go together. So 7 and negative 3 are like terms. Negative 5x and 8x are like terms. Okay, and again, a like term is something that has the exact same variable. If I combine like terms now, I have 7 minus 3, which is 4. You'll see that I'm going to go ahead and cross these off in a nice fashion so I can still actually see what I have, because most of the time that the errors occur here, somebody has transferred down the wrong number. So if you scribble it out, I can't actually see what you had written. Okay, so that defeats the purpose of actually asking for help in seeing what you did wrong. Continuing with the x's, I have negative 5x plus 8x, which is positive 3x. Okay, and to finish this problem out, I always stated that you had to have these written in standard form. And standard form is where you have a variable going from highest to lowest exponent. Okay, the only variable we have here is x, so that needs to go in the front. So this ends up being 3x, and that's a positive 4, so plus 4, and that's my answer. Okay, number two is similar, but it's subtraction in the middle. Again, subtraction in the middle means that we're going to take that second set or whatever is behind the subtraction, and we're going to just change the signs. Okay, again, my suggestion is to rewrite what you have without parentheses first. So this set's just going to drop down, so I have negative 9 plus x. Some of you may want to put a 1 in front of the x. Again, that's up to you. Okay, be your own advocate there. But again, this is telling me to change the signs inside here. So minus a negative 6 becomes plus 6. Plus 7x becomes minus 7x. Okay, and then again from here, my suggestion is to underline things in a similar fashion, okay, that are like terms. Negative 9 is a like term to 6. X is a like term to negative 7x. Okay, and then we're going to combine like terms. So negative 9 plus 6 is negative 3. X minus 7x is negative 6x. Okay, and then again, writing these in standard form, you're going to have the x first. So negative 6x minus 3. Number 3, last one here. My suggestion with these was to use the distributive property. Okay, again, some people call it FOIL, and FOIL is okay as long as we have a binomial times a binomial. But FOIL is preferred only for binomials times binomials. Okay, so if I distribute though, I take the first term here times the second set. So negative 1 times 11 minus 9x. And then I take the second term, so plus 3x, also times the second set. Okay, and then I take those monomials now that are outside the binomials, or the number that's outside the set of parentheses, and I'm going to distribute. Okay, so I'm going to take this and I'm going to multiply in to both of these items. And then I'm going to take the 3x here and I'm going to multiply in to both of these items. Okay, so negative 1 times 11 is negative 11. Negative 1 times negative 9x will become plus 9x. 3x times 11 is 33x, so plus 33x. And 3x times negative 9x becomes negative 27x squared. Okay, remember x times x is x squared because it's x to the first times x to the first. We add those ones together and it becomes x to the second, or x squared. Okay, again, combine like terms. So if you notice here, the only two that are alike are these two in the middle. Okay, so this becomes negative 11. 9x plus 33x is plus 42x minus 27x squared. And again, writing this in standard form, you're going to have the highest exponent to lowest exponent or no exponent, so that we have to actually switch the negative 11 and the negative 27x squared. So this is negative 27x squared plus 42x minus 11. Okay, the imaginary unit. Complex numbers are any number that consists of a real part and what is called an imaginary part. Okay, this is not like your make-believe friend, but it's an imaginary part of a number. Okay, standard form for any imaginary number is a plus bi, where a is the real part of the number. Okay, that will be an integer or some rational number that we end up with. And b is the imaginary part of the number. Okay, when you take standardized tests, a lot of times they'll give you a number like this, or give you something similar to one of these problems that we will end up doing, and they will just ask a question like, what's the imaginary part? Okay, and that's the value of b. Okay. So what is I? I is the imaginary unit. It stands for, numerically, the square root of negative 1. Okay, more important information to keep in mind about I is that I squared is equal to negative 1. I cubed is equal to negative I to the 4th is equal to 1. And I to the 5th is equal to I. Notice that the 4 of those, if we added those together, would actually cancel out. So negative 1 minus I plus 1 would become 0. In standardized tests, there's a lot of times where they have something like I plus I squared plus I to the 3rd plus I to the 4th, and then they put plus, and then it's like dot 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 plus I to the whatever else power, okay, called 99. And what they want you to know is that every set of 4, okay, from 2, 3, 4, 5, and then 6, 7, 8, 9, then 10, 11, 12, 13, those will cancel each other out, okay? So you have to work through the process there, all right? But more importantly, this goes back to the previous section of simplifying square roots. You will notice that I will have one of these problems on your quizzes and tests where I give something like, let's say, the square root, we'll say negative 48. And if you plug in this into a calculator, you're going to come up with a solution that says non-real number, or it will say error. Okay, and that's because it's an imaginary unit. What's going to happen is that we're still going to take 48 and we're going to find the factors of 48. Okay, and the factors of 48, 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. And again, I'm looking for that largest perfect square factor. So 48 is not it, 24 is not it, 16 is the largest perfect square, so we will use that set. Okay, but the difference between this one and what we've done before is I'm going to break it apart a little bit different. Okay, so please pay attention to that. This is going to become the square root. We again use that 16 first, the largest perfect square, times, I'm going to do -1 now, times 3. Okay, so I'm going to break this up into 3 pieces instead of 2. Okay, 48 itself is the 16 and 3, but we still have to account for that negative. Okay, so we're going to call that -1. We then apply the multiplication property of square roots, which means I can split this up. I can take the square root of 16 times the square root of -1 times the square root of 3. Square root of 16 is 4. Square root of -1, as you can see over there on the left side of the board, is I. So this becomes just an I. And then the square root of 3 remains at the tail end there. Okay, again, you will see problems like this on your quiz and test. So make sure you understand what to do with that negative. This will also come into play later in the unit when we start talking about quadratic formula and completing the square. Okay, operations we're going to look at, we are going to add, subtract, multiply, and divide. So we're going to do all 4 operations in mathematics with complex numbers. Okay, so in general here, I have 2 sets of parentheses. Again, I have 2 binomials, A plus BI plus the quantity C plus DI. And we're going to consider I to be something similar to a variable. So call it X or Y, but don't change it. Okay. So again, the reason for the bell work is the fact that we're going to do exactly the same thing. The only difference here is if we pay attention to that number 4, is that we have to put it in standard form, and the I is going to go in the back. Okay, so we're going to eliminate the parentheses here. We're going to combine the real parts, or the numbers without the I. We're going to combine the imaginary parts, again, or the numbers with the I's. And then we're going to put the results in standard form, A plus BI. Okay, so I would do nothing different from what we did with the bell work. I would start by rewriting this and rewrite it without the parentheses. So again, I'm going to take this first set, because this is addition. I'm just going to drop it down. Second set, again, same thing. I'm going to just drop it down. This is -3, so it's -3 plus 11i. I would still underline like terms. So 23 and -3, -14i, and positive 11i. And again, we're going to combine things. So we have 23 minus 3 is 20. And then -14i plus 11i is -3i. And that's all you do for addition. Okay, again, the exact same thing that we did for the bell work for adding polynomials. The only difference here is that the I term must be in the back. subtracting complex numbers, again, similar to what we did before. Now I have the quantity A plus BI minus the quantity C plus DI. Again, we're paying attention to that sign in the middle of the two sets of parentheses. Procedure-wise, you're going to rewrite the expression again, eliminating the parentheses, requiring us to change the sign of all terms in this set or sets, if we have multiple, behind the subtraction. Okay, and then the rest is the same as addition. We're going to combine the real parts, we're going to combine the imaginary parts, and then again, we're going to make sure that our answer is in standard form, A plus BI. Okay, so again, starting off the same as we did for bell work and the same thing we did for the last problem. I'm going to take the first set. I'm going to just drop it down. So 2 minus 7i. And then again, this tells me to change signs. Okay, of everything inside of there. So this positive 4 inside the parentheses becomes minus 4. Okay, this negative is not attached to that 4. It's what's inside the parentheses. Okay, negative 9i becomes plus 9i. Again, then underlining like terms, I have the 2 and the negative 4. I have the negative 7i, and I have the plus 9i. Again, starting then 2 minus 4 is negative 2. And then negative 7i plus 9i is plus 2i. Okay, and again, making sure that it's in standard form, the I is in the back. So that is correct. Next page here, this is a little bit different, so make sure you pay attention to this. There's one step in particular that is a little bit skewed from what we did for the bell work for multiplying polynomials. Okay, so in general here we have the quantity A plus BI times the quantity C plus DI. And the procedure is we're going to distribute the expression, again similar to what we did before. We're going to combine any like terms, again similar to what we did before. Now the difference is we're going to replace the I squared with negative 1. Okay, because if you can remember that slide, I think it was the third slide, stated that I squared equals negative 1. We're going to put that into play now. Okay, so we're going to replace I squared with negative 1 and simplify. Okay, step 4, then you're going to combine any like terms again. In step 5, you're going to write the expression in standard form. Again, A plus BI. Okay, so I have the quantity 5 minus 7i times the quantity negative 12 plus 5i. Again, I'm going to use the distributive property, so I'm going to take the first term, or 5, times the second set, so negative 12 plus 5i. Second term, so minus 7i, times the second set, so the negative 12 plus 5i. Okay, and then once we have this, we're going to distribute, so 5 times the negative 12 and 5 times the 5i. So 5 times negative 12 is negative 60. 5 times 5i is plus 25i. And then I'm going to take negative 7 times negative 12, and negative 7 times that 5i. We have negative 7i times negative 12, which becomes plus 84i. And then negative 7 plus 5i is negative 35i squared. Okay, and again here then I would simplify and combine like terms. That's the middle two terms here. So that gives me negative 60 plus 109i minus 35i squared. From here then, the next line down, I'm going to replace that I squared with the negative 1. Okay, so you're going to rewrite it exactly the same, but I'm going to remove that I squared and replace it with negative 1 in parentheses. Okay, so then I'm going to multiply those two. So that gives me negative 60 plus 109i plus, because it's negative 1 times negative 35. And then again, now I have two like terms. Negative 60 and 35 are like terms. So combine those. So negative 60 plus 35 is negative 25 plus the 109i. Okay, so again, the difference here is when we get to this point, we replace this I squared with negative 1 in parentheses. Okay, and then we multiply. Several of you will be able to skip some steps here. I'm okay with that. Again, as long as you're able to do it. Okay, so if let's say here, instead of writing I squared, you just wanted to write negative 1 in parentheses first, that's okay. Again, you need to be your own advocate here and write down as much or as little as you need to. Okay? Okay, now for dividing complex numbers, this is where it's time consuming. We're going to essentially break this apart to become two multiplication problems. Okay, but there is a new step here. We're going to be taking a plus bi divided by c plus di, and we're going to take and find the conjugate of the denominator. Okay, so if I'm looking at the numerator there, the a plus bi, the conjugate of that is a minus bi. Okay, so hear what I'm saying here. You are going to change the sign on only the I term. Okay, I don't want you to change the sign on a number in front, so that a value, whatever it may be, will still stay a, but the conjugate is going to change the sign on the b term. Okay. The conjugate of the denominator for that general equation there, if I have c plus di, then the conjugate would be c minus di. Procedure there, you're going to multiply the top and the bottom, or the numerator and the denominator of the fraction by the conjugate of the denominator. And you're going to repeat all the multiplication steps for the top two. You're going to look at the bottom two and repeat all the multiplication steps. And then you're going to write your expression in standard form. You will need to separate these so that you see an I or an A term and a B term for standard form. Okay, so two examples here. One where I have a binomial in the denominator, and then the other where I have just a monomial. Okay, so I want you to be able to see both cases here. So I need to find the conjugate of the denominator, which means we're going to look at this expression. And again, all I'm doing is taking whatever this I term is and changing its sign. So it's 2 plus 3i, so the conjugate is 2 minus 3i. And again, I'm going to multiply the numerator and the denominator by that exact same thing. Okay, then my suggestion is to break this up, right top. And then take these two and multiply. So I have 6 minus I times 2 minus 3i. Again, I'm going to use the distributive property because I have the ability to do so. So 6 times 2 minus 3i minus I times 2 minus 3i. Working it down, 6 times 2 is 12. 6 times negative 3i is negative 18i. Negative I times 2 is negative 2i. Negative I times negative 3i is plus 3i squared. Again, then working this down, we're going to combine like terms here. So I have 12 minus 20i plus 3, and I'm going to replace that I squared with negative 1 like we did in the last problem. 3 times negative 1 is negative 3, so I have 12 minus 20i minus 3. Again, combining these, I have 9 then minus 20i. Okay, that's only the top portion. We need to find the bottom portion as well. Okay, so I'm going to do that in red here, so the bottom. Or sorry, green, I said red. I don't know why. Green here, I'm going to look at just the denominator. So I have 2 plus 3i times 2 minus 3i. Again, distributive property 2, first term, second set, times 2 minus 3i. Second term, so plus 3i, times 2 minus 3i. I. Distributing then, 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is plus 6i. 3i times negative 3i is negative 9i squared. Okay, and the reason that we multiply by the conjugate of the denominator is because we are trying to rationalize the denominator. And if you remember previous units, rationalizing the denominator means that you're going to put something in the denominator that is a rational number. Okay, it cannot be a square root. It cannot have an I in it. It has to be a rational number. So you'll notice here that negative 6i and 6i in the middle should cancel out. Okay, that should happen every time. So these two here should end up canceling. And then we continue. So we have the 4, and then we have the negative 9 times negative 1. Again, replacing I squared with negative 1. So I have 4 plus 9, which is 13. Okay, and then to finish this up, we're going to take each part of the top and then divide that by the bottom. Okay, so I have 9. Right answer here. 9 over that 13. We're going to simplify that if possible, but we can't reduce that here. Minus, and then I'm going to just take the 20 and then put it over the 13. And then an I goes right next to it. Okay, so we have 9/13 minus 20/13 I. The real part of that is 9/13. The imaginary part would be negative 20/13. Okay, but you will need to separate that for your answer in order to receive full credit. Okay, number 2 is a little bit different. Again, I have a monomial in the denominator instead of a binomial. It's still the same principle here. We are still going to change the sign on the I term. It's only an I term. Okay, so I'm going to multiply the top and bottom here. By negative 5i. And again, I'm going to go ahead and separate the top. I have negative 3 plus the 7i times the negative 5i. Okay, here, I don't have to break it apart like I did in this one at this second step because I only have one term here. So I can just take this and multiply. So this times this, and then that times that. So negative 5i times negative 3i is 15i. 7i times negative 5i is negative 35i squared. Again, then looking at I squared and knowing that it's negative 1, I replace that. So we have 15i minus 35 times negative 1, or 15i plus 35. And then again, we have to interchange these because I has to go in the back. Okay, so the top portion is done. The bottom then. We have 5i times negative 5i. 5 times negative 5 is negative 25. I times I is I squared. Again, replacing that I squared with negative 1 gives us now negative 25 times negative 1, which is positive 25. And again, for my answer now, I'm going to take each part of this numerator, or the top, and divide it by the bottom. So I have 35 over 25 plus 15 over 25i. The difference between that one and this one is that here, these fractions were already reduced. I'm going to leave them as improper fractions. I don't want to see mixed numbers. But the ones over there on number 2 are not reduced. So I can simplify 35 over 25. I can divide both of those numbers by 5. And then the 15 over 25 can also be reduced by dividing both of those by 5 as well. So this ends up being 7 over 5 plus 3 over 5i. Okay. Take your time. Again, the division problems will become very long in comparison to the adding and subtracting, obviously. But again, we can break it up into being 2 multiplication problems. So it shouldn't take much. Take time, use a separate sheet of paper if you need to, and write out the top and the bottom like I did here on the board, and you'll find that it helps significantly. Okay. Again, as always, if you have any questions, comments, or concerns, please feel free to reach out to me and let me know.